Hey folks, Doug Blake with Body Design University. Merry Christmas and welcome to another of our weekly studies. Today, we're going to talk about heart rate reserve and VO2 and metabolic equivalence. I saw a post where there was some confusion. One of the students obviously was just asking for, kind of an explanation of what heart rate reserve is, what VO2 is, Vo2 Max, Vo2 reserve, all of those subject matters that are spoken to in the ACE and in particularly the 6th edition. Now, here's what I will say is that just keep in mind that there's always going to be two things that you're concerned with when you're going through the actual textbook. One, of course, is that you got to memorize material, memorize information so that you can pass the test, meaning that the information that's in a particular area of a particular chapter needs to be memorized well enough to where you can answer those particular questions. And yes, the questions are challenging. If you've gone through any of the quizzes or any of the practice exams, they can be challenging. So you got to know the material, obviously, to navigate through those through those questions. The other part of this, and I hear this all the time, is how do I use this in the real world if I'm going to use any of it at all? And this is where there can be some confusion when you're studying. Quite often what will happen is you'll go into an area chapter and it could be a little confusing. And then you start going back and forth. Well, how would I use this? I need to memorize this. And then you start thinking, when I'm actually training somebody, is this really relevant? So what I want to just make sure you understand right from the get-go, when you go to study as if you're just trying to memorize the material to pass those questions, to pass the exam, okay? You can go back. Look, once you pass the ACE exam, you pass it, get your high fives, post it in the group that you passed, right? That's great. Now you can go back and make determinations or decisions as to what you would use when it comes to the materials when you're actually training people. Remember, excuse me, your business model determines a lot as to the assessments and the other information related to exercise physiology, which is what we're talking about here. HRR, or heart rate reserve, VO2, Vo2 max, Vo2 reserve. All of that is more in-depth exercise physiology. So when you're reading through this particular chapter, I believe it's chapter 8, when you're reading through it, just keep in mind, you're getting a ton of information that for the most part is not going to be asked on the test, but you never know. So you want to understand it as best you can. ACE, I believe, did a great job in their 6th edition by kind of making things simple. They're really, believe it or not, in the 6th edition, trying to help you to navigate the real world of training, believe it or not. That's one of the reasons why they don't spend an inordinate amount of time discussing VO2. So this particular topic, and by the way, you don't need to know a whole, when it comes to actually training people, you don't need to know a whole lot about VO2. In fact, what ACE did, and I think it's a great, they did a great job on this, is they focus on ventilatory threshold, which actually is the most effective, most real way of dealing with cardiorespiratory training and those variables needed to understand intensity. Because let me go ahead and pull this up. Because at the end of the day, heart rate reserve, VO2, they all are focused on the intensity. Now, you remember when you're going through chapter 8 and they start to talk about those different variables of duration, frequency, they're going to tell you correctly that intensity is probably the single most important variable that you deal with when it comes to cardiorespiratory training. So just keep that in mind. The use of heart rate reserve, or VO2, and sometimes you'll see it as Vo2 max. You'll also see Vo2 reserve. These concepts, these ideas are in the world of exercise physiology and are needed during more specific type of testing and understanding a particular person's physiological adaptation to cardiorespiratory testing. In the real world, right, when you're training people, don't worry about any of this, right? Your basic focus is going to be on ventilatory threshold. And that's what ACE is going to tell you. ACE gives you the information and says, look, this is great. This is interesting. Heart rate reserve, Carvonin method. metabolic equivalence, which is what goes with VO2. But you can basically put all of that aside and focus on ventilatory threshold. So that's why I'm just giving you sort of a preliminary so you understand, know this information so you can pass the test, so you can answer the questions correctly. Now, I just grabbed this from chapter 8, so it's figure 816, and basically it's talking about the use of the Carvonin method. I'm going to go ahead and pull a pen up here so I can kind of draw this for you as well. And basically, heart rate reserve is a very simple calculation. Its use basically for the trainer, for the average personal trainer, is to create a more accurate assessment, right, of what the heart rate or what a person's training heart rate should be at a certain percentage. Now, I don't want to get so deep into it that we forget. This is just a weekly study. I want you to get sort of an overview and understanding. And you'll notice, believe it or not, that when you read this in chapter 8, ACE doesn't go into it to any great extent. They give you some information, of course, on some research studies. And by the way, the research that has been done since the 1940s in this, in the 1950s, a lot of research was done in the 60s and the 70s to help sort of clarify some of the questions that researchers did have as to what were better ways to gauge training intensities and whether or not they were actually beneficial for the average person. So that's where a lot of this data comes from. But heart rate reserve itself is a very simple calculation. All we have to do, right now, and I say that, half jokingly, is get two pieces of data. One of those pieces of data is pretty accurate and very simple, and that is your resting heart rate. All I got to do is have you sit down and get your resting heart rate, 60 beats per minute, 70 beats per minute. The other piece of data, which makes it a very simple calculation, is not as easy to get, and that is your max heart rate. I don't know what your max heart rate is. If you've ever used the 220 minus your age calculation, that could be way off, and generally is way off depending on your age. Just keep in mind the 220 minus your age calculation, ironically enough, the researchers that came up with it, they never wanted that to be used. It was never to be used on a regular basis for the average person in an exercise environment. It's research that was being used. And so the estimated maximum heart rate for an average human using 220 minus your age way overestimates younger people and generally underestimates older people. And so this is why we have what's known as the Carvonin method, and that's up over here. And you can read more about that. And the Carvonin method basically just uses heart rate reserve as a way to increase the accuracy of what we're going to term the actual training heart rate. Okay, so if you'll notice when you look at this equation, that is the simple Carvonin equation. We use heart rate reserve simply to increase the accuracy. If you use 220 minus your age, it is what it is. It's not very ironic. I'm just telling you, it's not very accurate. But if we use the Carvonin method, what we're going to say then, or the heart rate reserve method, is we're going to look at this guy right here. And this is the information that's a game changer. And that's why it's used, because we know that the lower, everything else being equal, the lower the resting heart rate, same individual, same body weight, same age, same everything, if you could find that, a lower resting heart rate that's not pathological generally indicates a greater level of physical capacity or output. Okay. And so if you have a lower resting heart rate, you're generally in better cardiorespiratory condition. Okay. Everything else being equal. And so a 25-year-old or 30-year-old, you have two people that are 25 years old, two people that are 40 years old. If you use the 220 minus your age, then the estimated max heart rate, right, is going to be what it is. Okay, well, that's not going to change whether you're 25 or 30, whatever it is. However, that same 25-year-old and this 25-year-old, this guy over here trains 5-6 days a week and does marathons, and this guy's a couch potato. Well, what do you think their resting heart rate's going to? What do you think their training intensities are going to be? And how do you think their bodies are going to respond to different percentages of, quote, max heart rate? They're going to be different. Well, what is the one indicator that will help us to understand that? It's their resting heart rate in general. So that's why we use this heart rate reserve technique. And all it is, there it is, your max heart rate, right? Your max heart rate minus your resting heart rate. And that gives you what's known as your heart rate reserve. And there's your calculations. Of course, you can read up over in the sidebar. We use this if we already have a percent of max heart rate that we're going to use. Okay. So even this methodology, although it's a little bit more accurate, still for the most part is not the best way to deal with the training scenario for the average person. So you're given this information. It's all well and good. It's down and dirty, simple. You get your numbers, take your percent. In this case, they were using, say, 70%. And then this would be the training heart rate for that individual with a resting heart rate of 64 beats per minute. That's great. Look, for the most part, you can get people started on something like this. But if you want it to be really accurate, okay, if you want it to be really accurate, you wouldn't even use percent. And this, by the way, is based off of Vo2 Max. Okay. So if you had your Vo2 Max and you got tested for it, okay, you can find out a pretty good amount of information about an individual. For the most part, that's simply not going to happen for the average client. That's why we use ventilatory threshold, right? And that's why we use the zone type of training scenario, which is what you find in the IFT model. Vo2, again, the question that the student had in the group was, what are these things? How? Well, normally the way ACE wants you to understand is that Vo2 really does not have a whole lot of functionality in the real world of training, but the metabolic equivalents that go along with Vo2 actually do. And that's why I put up table 8.8. So you can see METs of common physical activity. This makes much more sense. And by the way, it's a whole lot more, makes a whole lot more sense to the average client when you talk about something that's more indicative of their daily life. And all a MET is, metabolic equivalent, is that there's an assumed rate of oxygen consumption and usage. 3.5 is the number that is used, and that is equivalent to 1 MET of oxygen usage. If I do an activity that is, say, 2 METs or 3 METs, it's basically saying that activity is basically 2 times or 3 times higher than the number of METs that I use, just sitting here doing nothing. It makes more sense because the average client can understand that walking slowly involves a little bit more oxygen consumption usage than just sitting there. And then, of course, you have all these vigorous exercises, right? Walking, jogging, running. I'm not saying this is what you use. However, you'll notice that on some of the machines that people use, like treadmills and stair climbers, actually have built into the computer system on the screen the number of METs for that type of activity. Now I can equate caloric value, all of these things. That's great. But in the end, as a trainer, I'd rather use ventilatory threshold and put you through zone training. It makes it a whole lot easier. So this idea of Vo2 is the volume of oxygen that's being brought in and used by the body. Amount of oxygen over the amount of time that it's being utilized. So Vo2 and Vo2 Max. Vo2 Max, simply the maximum amount of oxygen utilized. And that's where the max comes in. And again, that's why ACE does not go into it to any great depth. And so they want you to understand this information so you can answer some questions. And it's not like you have to memorize all of these, exactly what these are and what their numbers are. That doesn't make sense. intuitively, you know what the high intensity or high met values are, and moderate, and then of course light. It's just for the average client, it's simply a matter, and for you taking an exam, simply a matter of you just kind of estimating this type of activity. Does it involve a lot of exertion, moderate exertion, or high exertion? And that's basically all that's telling you. And so just keep in mind, the idea of doing the weekly study was not to go in depth into the explanation of VO2 or VO2 max or VO2 reserve. That's not the point of this. And in fact, that's not the goal when you're going through their textbook. If it really is of interest to you, then you can move on and Google a more in-depth search of the particular subject. What ACE wants you to do is to utilize this information ultimately to get you to ventilatory threshold so you can use that within the IFT model, right? And get into the zone training model. I hope this was helpful and effective. Again, Merry Christmas. Have a safe holiday, and we will see you next week. Thanks.